So this is level 2. I can't believe it, guys. You guys made it through level 1. Applause. I'm already clapping here at home. So the next thing we're gonna do is, well, we're gonna do level 2, of course. And guess what we're gonna do in level 2? Well, in level 2, now we're gonna take the parts that we learned about, and every now and then we're gonna have a new part too. But we're gonna put them together instead of just using one part at a time. So in this case, we're gonna make, as you might see on the top, a robot elbow. We are getting so close to making the robot, even though we are only 2/20ths of the way, or 1/10 of the way. But, well, we're gonna learn an elbow, how to make the elbow. So, this is a new part you might have seen. It's called a micro servo. And there are bigger ones too if you're making a big machine or something. But, well, there's two types. There's positional, which is the one that most people have, which is the one that can go from 0 degrees to 180 degrees, even though they don't go exactly that much. And then there's continuous, which means it's pretty much like a motor. But most people will have a positional. And I'm going to name this the elbow bone. Because, you know, when you move your elbow, there's a bone there that can twist. And that's what this servo is going to be. It's going to make sure that the elbow can twist. Even though we're going to make sure that it only goes from 0 degrees to a little over 90 degrees. So then we also have the potentiometer. That's what we're going to do for now. That way we can move it up and down. And the reason why actually we're so far to making a robot is because we still got to make sure that the robot can understand you, that it can talk and stuff like that. So it's got to be able to have pretty much like a human brain. So we're pretty much going to make a robot of a copy of a human on the way in. So stay tuned because it's gonna get super duper hard levels. And there are wires everywhere, by the way. So, well, first of all, we've got to do some work. We are going to start the coding after, but for now, we are going to just connect all this. So first I want to twist this servo a little bit so I can go connect it easier. And first of all, we need to connect our positive and negative ones. So a black wire from ground to ground, to ground, and then a red wire from positive to positive. Now we're going to take an orange wire from signal here to these PWM pins, okay? So I'm going to do number 10 for now. Oops. There we go. So, oops, I don't want that thing there. So, we got that. So we got this connected. Now, all we need now is we need to connect the potentiometer so we can control it. The next time, on the real robot, we will be able to control it. But not only that, it will be able to also control itself. So, we're going to connect the black wire to the, you know how potentiometers work by now. I'm not going to explain anything unless it's a new part. But in our case, we're going to use a yellow wire for the wiper, which is what that middle pin is called. And we're going to connect it all the way around to, let's do analog pin and digital pin 9. Let's do. So now let's get into the code. But before we do that, I want to show you a few little things about what this thing can do. It's quite amazing how this servo can do a lot of things. So we have positional, continuous. So the continuous is still kind of like a motor now. But it's really not useful then. I'll just get a motor instead of a continuous micro server. So I'm going to have positional. So that's how we're going to control how many degrees the elbow is moving. And if you put your hand out straight, here's an exercise. Move your elbow back and forth. So that's what we're really trying to do right now. Even though we won't have everything. I'm actually now having a lot more things, like the list of items that we need. servo, which is called elbow bone. Should probably put a space in front. But if you are on Tinkercad, it actually shows you everything here. So, yep. So, see you back. First, in here, we're gonna go hashtag include inside there servo.h. Now the next thing we're going to do is we're going to create a variable on where the potentiometer is. So constant of type integer called pot. Pot is short for potentiometer. Equals. Let's set it to I forgot that it isn't on an analog pin. So we're just going to need to put it on an analog pin. We'll change it later. The next thing we're going to do is we're going to create another variable of type servo. So we go servo. Let me actually copy it from here. Because it's called right elbow, but don't really. I'm not that good at writing camel case. So servo, right elbow, and we don't really need to set it to anything yet. Now, in the setup, setup, we go right elbow, which is the elbow's number. Not number, but the name, of course. Dot attach, which means we attach it to a certain pin. And this pin is going to be pin number 10, I think it was. Yeah, I'm pretty sure it was on pin number 10. We'll double check that later and change it. Now in loop, I can close setup. But in the loop, what we're going to have is we're going to have 3 lines of code. Int reading, I'll set that to something. Reading equals something. And then we have right elbow dot so and so. Anyways, now we're just going to go into reading equals analog read the position of the servo. And that's quite easy actually. When you read, I know it's not a analog pin, but you should know by now what analog. Actually, yes, it is an analog pin. Yes. But you should know by now. If it were analog right, and we would be using a digital pin, you should know by now what that means. Now, in reading, when you set reading equals reading, not reading equals reading, it's reading equals reading divided by a certain number. And I actually need to look this up again. The number is 1000 divided by 180. That gives us, so 100 divided by 180 gives us an output of 5.55555556. Copy that and paste it in here. Slashes for dividing. Right, then the last thing is we go right elbow dot right, like that kind of right, like you write down, but that's how you write it at least. I'm using the word right a lot. So the servo name dot right, and then you give in how much you want to do it. So this function here comes from the servo library, which we just included, and that there is for spinning a servo to a certain direction. Now here we go reading because we need to get the reading of it. So the reading of the potentiometer. And the reason why we need to divide, I'll explain right now. Because so if I turn the potentiometer a little more than a third, the servo will start spinning backwards because that's what the analog read and the analog write function does, which is similar to what's actually happening. So what it does is it spins it to that certain position. But if we spin it too much on the, well, not too much, that's not really a thing, but if you spin it more than a third on the potentiometer, then it'll start spinning backwards. That's why we need to divide it by that amount to get this number. I'll have this number actually in the description. That way you don't need to really calculate it. But this is the code. I'll open up the void loop and void setup functions here so you can see everything. Now, let me go over this again. Hashtag include servo.h includes the library. Constant pot equals a0, semicolon. This makes a variable called pot to hold the pin that the potentiometer is on. Then servo right elbow, semicolon. This is creating a servo variable and using the right elbow, called right elbow. That way we can use that later on. Now in setup, void setup, and in the function, we go right elbow dot attach 10. This attaches the servo called right elbow to digital pin 10. The next thing we do is we're done with the void setup. Now in void loop, we create an integer variable called reading that is set to analog read pot, semicolon. This means that we read the data from the potentiometer, how much it spun. You should know that already. Now, reading equals reading divided by 5.555555556, semicolon. This makes sure that anything that way if we turn it more than a third, it will continue spinning correctly, not backwards. Then we go right elbow dot right reading, semicolon. This tells the servo to go to that specific position stored in the variable reading, which we made and edited twice. So let's go ahead and upload this using the upload button, but you gotta still go to tools. Board is an Arduino Uno, port is, and then whatever it's connected to. It's probably going to be COM1, COM2, or so on. But for now, we're not going to do it like that. But really what you're going to do is you're going to press the upload button when your Arduino is connected to the computer, using that blue USB cable which comes with the kit. Anyways, the next thing that we're going to do is, copy all of this, that way I can actually simulate it in the simulator called Tinkercad. I have a link to the description. That's also how I am making games, by the way, for my websites. And go to codewithmarley.wixsite.com/games. That will bring you there, and it'll be in the link in the description, so you can go there, and as well as my website. Go down to the parents view, please. But kids, make sure that you guys don't search anything up online unless you're using Kiddle.com. That's what I recommend. Parents, if you're here, please download it. They should be here right now. Anyways, I'm going to save this. And what should I call it? I don't want any copyrights. I want to call it... What should I call my robot? Let me call it Flow-Mo. And we go _elbow. Now, later on, we're going to learn how to do it with multiple ones. So, see there, we're getting quite close to making the robot. So, we're not only going to make a human robot, not really human robot, but something that is similar to a human, that can have pretty much all the abilities that a human has. Not only that, we're also going to try to create our own little pet for it that it can interact with, or whatever, pretty much whatever you want to do. That's what this whole learning is all about. Learning how to make your own robot. We will be doing apps soon. Can't wait. If you go to my website, codewithmarley.wixsite.com/codewithmarley, which is also in the description, you'll see a button called Coming Soon. If you press on it, it'll show you two different things that you can do to get ready. One, to get ready, buy a Mac. So it's just going to be for Apple stuff. So it will be a little expensive, but you'll have to get your own Mac. Sorry, kids, if your parents don't want you to, but it's okay. Robots are cool too. quite fun. So let's go ahead and get right into it. Let me save it. Underscore elbow, I'm going to do that, but we know that it's an elbow. It's slow-mo elbow. Sounds a little weird. Now we will learn how to do it with multiple ones in a few more videos, because there's a separate board that we need to use. And that also includes the library and completely complicated stuff, probably in level 5 or 6, which is quite a way away. So let's go ahead and copy all this and go to the, you're probably going to press the upload button, but in my case, I'm going to copy it all, and there we go. I've connected the yellow wire to analog pin 0 instead of 9, and in the code section, I'm going to paste the code and start simulation. Let's see how it goes. Okay, so we're here. Servo is not turned. Turn the potentiometer. Turn a little bit. Good. Straight up. Straight up. And actually, it would be better if I didn't have it reversed. So to do that, I'm going to turn this red, connect it to that. Turn this black and connect it that way. That way, it is actually the correct side. So now, if I turn it to the right, the servo turns to the right, instead of being otherwise. There we go, turn it to the left, and it starts going to the left. And actually, I think there's a little, yeah, if we go to continuous, what it does is it pretty much just starts spinning at a certain rate. Straight up means that it goes slow. The more you go to the side, the more it speeds up. But in our case, we don't want it like this. We want it to be positional. That means it spins to that position that the servo is pointing. So I want it to point this way. So the servo goes exactly where I'm pointing it at. And this is actually quite useful, because this is how you can make your knees, your the arms, the hips. This is quite, we're going to need like a lot of these though for making a robot. So we're going to start off with making a little pet for the robot when we're done. So the first thing is here. So see you guys next time when we, well, I don't think that's really going to be the time, probably level 5 or 6, that we start getting into multiple servos, because we need a separate board. Anyways, we got like this. See you soon. Bye.